Hello class, in today's video we're going to be solving quadratic equations using the factorization method. So the learning intention is to learn how to solve quadratic equations using square roots, to understand that for the product of two or more numbers to be 0, this means that one or both of the numbers must be equal to 0, and lastly to be able to apply the steps required for solving a quadratic equation using the null factor law. Now, if you guys recall from our previous lessons, we looked at sketching parabolas where you had to identify the y-intercept as well as the turning point. And I said that this is going to give you a rough sketch of what the parabola looks like. But if you wanted to actually enhance it and make it more accurate, what you also need to find is what the x-intercepts are. And that's pretty much the main focus of today's lesson. So when you're trying to solve what the quadratic equation is, essentially what you're doing is you're trying to find the x-intercepts, and this will therefore help you draw an accurate parabola, okay? And there are various methods that you could actually use to solve the x-intercepts. You could do this by using the square roots, which we'll be doing in today's lesson. You could factorize and then apply the null factor law, which we'll also do in this lesson. But we could also complete the square and use the quadratic formula, okay? And these are we're going to be looking at in separate videos, so that's for future lessons. And I said that for factorizing, I showed you various ways that you could actually factorize. So we did that by using the highest common factor. We looked at DOPS, the grouping method, as well as the product sum method. And I'm hoping that you guys have a solid understanding of these methods, as this will make this a lot more easier for you to understand what I'll be showing you in today's lesson. So the first thing I want to talk about is how do we solve quadratic equations using square roots. So the square root method involves isolating the x squared in the quadratic equation on one side of the equation, and then you solve for x by pretty much reversing or undoing the squared sign by using a square root, okay? So for instance, if you have a x squared, what you're doing is you're square rooting this, and because they're inverse operations, they will cancel each other out, and this will allow you to isolate or solve for x, okay? Now, this particular method will only work under certain circumstances. So the first circumstance that you need to be aware of is that this will only work when it does not contain any x term, okay? So what do I mean by this? Now, recall that the standard equation for a quadratic is ax squared plus bx plus c. Now, this is saying that you don't actually have an x term. So that's your x term over here. Essentially, what that means is b is equal to 0. So therefore, it will only work when a quadratic equation kind of looks like this format over here. And I've got an example. So in this example over here, this would work, but the example on the right hand side won't work because this is not equal to 0 at all, okay? And the second condition is that the number must be able to be square rootable, if that's even a word, okay? And we know that only positive numbers can be square rooted. So if you put this onto the calculator, you can square root 8. However, you can't square root to any negative numbers. In this example, negative 16, you cannot do. So let's look at a couple of examples. So in order for you to solve it, what you need to do is put your x squared term on one side of the equation and put your constants, meaning your numbers, on the other side of the equation, okay? So in my example, x squared minus 15, I'll actually move 15 to the right-hand side. So I add 15 to both sides. These are inverses, so these will essentially cancel each other out. Therefore, x squared is equal to 15. And once you've got it into separate sides, then you can solve for x by square rooting both sides of the equation. So if you square root this, therefore, it's going to give you positive and negative 15. Now, why does it give you positive and negative? Well, in this case over here, you'd know that if you went, for instance, negative 3 times negative 3, that will give you positive 9, but also 3 multiplied by 3 gives you 9. So it's essentially we're using this exact same concept to give us your answer. So if you square root any number, it's always going to give you both a positive answer as well as a negative answer. That's what this symbol over here means. So, but what I prefer you actually do is you actually just separate this and write this as positive root 15 and negative 15. Again, notice in this case over here that the square root 15 or 15 is not a perfect square at all. That's why we have to use surds in this case over here. Look at my next example. So this is a tier above this, just in terms of difficulty. In this case over here, we're going to solve for x. So therefore, I'm going to move 1 to the other side. So therefore, what I'll do is I'll add 1 to both sides of the equation. That will get rid of this over here. X squared is therefore going to equal to 25. We know that 25 is a perfect square. Square root both of them. And therefore, when you square root, it's going to give you a positive answer as well as a negative answer. So it's going to give you positive and negative 5. But as I said, it's always recommended that you just write this as x equals to 5. Or x is equal to negative 5. Now, it's really critical that you write the word or and not the word and this is not going to make sense for you right now. But when we do application questions, you'll see why you use the word or as opposed to the word and, okay? So for now, just get into the habit of writing this in your answer. And for my last example up here, 3x squared plus 7 is equal to 55. Again, we'll do this exact same process. So I'll subtract 7 to both sides of the equation. This will get rid of this. And therefore, I'm left with 3x squared is equal to 48. Now, in this case, to get rid of the 3, the coefficient, I'll divide both sides by 3. This will give me 16. And notice 16 is a perfect square. And therefore, if you do the square root, it's going to give me positive 4 or negative 4. Now, again, I just want to go through the limitations with this method. As I said, it doesn't work when the quadratic equation does not contain any x terms. So for instance, over here, notice that you've got a quadratic trinomial. And in this case, if you were to try to do this, some of this working out that I often see students do is that they'll move the 10 to their side. But if you do that, then what can you do? So you can't really do anything else once you've done this step. So don't actually do this at all. And another limitation, as I said, that you can't actually square root a negative number. So for instance, see my equation over here. It looks like you could actually do it. But as I said, you have to actually isolate the x's to one side, the constants to one side. So if you subtract 4 both sides, okay, this looks good. But notice that now you've got x squared is equal to negative 4. And as I said, you cannot square root a negative number at all. So therefore, this method won't work. So please be aware of these conditions over here. Another common mistake that I often see is that, as I said, you cannot forget to include the negative solution after you apply the square root. So in this example over here, you've got x squared is equal to 4. Most students in this case, when they do this, they would recognize that there's one solution. So they'd say x is equal to 2. They often forget the negative answer as well. So make sure you include this as well, okay? So that's the common mistake that I often see. What I want you to do right now is I want you to give yourself 5 minutes to answer these 3 questions over here, and then we'll compare our answers together. All right, for the very first example up here, this is a more straightforward example. So all you need to do is apply the square root to both sides of the equation. This will therefore give you a positive and a negative 12 in this case over here. Make sure you include both of them and include the word or as well. In this second example, we have to isolate x. So let's move 4 to the other side. So I want to add 4 to both sides of the equation. Therefore, 16 plus 4 is going to give you 20. Divide both sides by 5. X is therefore equal to, x squared is equal to 4. Take the square root, x is equal to positive or negative 2, okay? And for my very last example over here, it's just a bit more complex. So let's collect the like terms. So I want to subtract 15 on both sides of the equation. And in doing so, this will now give me negative 2x squared is equal to x squared minus 27. Let's do the x squared to the other side. So I'll subtract both sides by x squared. Therefore, I'm going to get negative 3x squared is equal to negative 27. Divide both sides by negative 3. And then apply the square root on both sides. Therefore, x is equal to positive or negative 3 as my answer. We're now going to be looking at the second part of today's lesson, which is about factorizing and understanding what the null factor law is. So the null factor law states when the product of 2 factors equals to 0, meaning if you multiply 2 terms or 2 numbers together and they are both equal to 0, then this could either mean one of the factors or one of the terms is equal to 0, or alternatively, it means that both of the factors are equal to 0. So what do I mean by this? I can represent this mathematically. So say that this is my first term here, which is in A, and my second term represented by B. If you multiply these two and the product is equal to 0, the implications is that either A is equal to 0, either B is equal to 0, alternatively, both A as well as B is equal to 0. So why does this make sense? Okay, well, if we just use regular numbers to demonstrate this, we know that any number multiplied by 0 will give you 0 as an answer. That's why it's saying either one of its terms is going to equal to 0. Alternatively, it could mean that both of these terms equal to 0, because we know that if you go 0 times 0, this gives you 0 as well. So that's what the theorem suggests. So how do we actually use this to solve and find out what your x-intercepts are going to be? Well, we already know that if you were trying to find the x-intercept for any given equation or any type of graph, what we did was we substitute y is equal to 0 into the equation and then rearrange to solve for x, okay? So in this case, notice that your x-intercepts, your y value is equal to 0. That's the reason why we sub y is equal to 0 to find the corresponding x value. So we know that to find out your x-intercept, we need to sub y is equal to 0. But what you also need to do is you need to be able to factorize the quadratic equation, and then you can actually proceed to use the null factor law to find the x-intercepts. So I'm going to show you in this example of here what I mean by that. Notice in this example of here, I've already included the equation as well as this graph, and you can clearly see that your x-intercepts equal to positive 3 and x is equal to negative 1. I'm going to show you why that is in this case of here by actually showing you the calculations to support this. So in this case, I'm going to factorize x squared minus 2x minus 3, okay? And I'm hoping that you guys are able to do this. And once you factorize it, sub y is equal to 0. So therefore, this is going to be my answer over here. And just to quickly double check, how do I know this is correct? Negative 3 multiplied by positive 1 will give you negative 3. And if you go negative 3 plus 1, that will give you negative 2. So that's a quick way of checking to see if your answer is correct. Now, once we've done this, then we can proceed to use the null factor law. The null factor law says that if you multiply any terms together and they equal to 0, either this bad boy over here is equal to 0, or either this bad boy over here is equal to 0. So what you do is for each term there is, or each factor, you equate them to 0 because either one of these could potentially be equal to 0. So therefore, you can go x minus 3 is equal to 0, or x plus 1 is equal to 0. And now notice I've got these very simple equations here. I can therefore solve for x. So therefore, if you use inverse operations, x is equal to positive 3 and x is equal to negative 1. And I'm hoping right now that you're able to draw links in from the previous lessons and see the importance as to why we actually need to factorize in order to solve for our x-intercepts. So I'm going to go through a couple more examples. So this example over here is factorizing using the highest common factor. So in this case over here, what I'll do first is I'm going to rearrange the equation. So I'm going to move the 16x to this side over here so I can actually factorize it. So if I move it, I'm going to subtract 16x on both sides. Therefore, this is what my equation would look like now, okay? In this example over here, your highest common factor is going to be 16x. And therefore, if I factorize it, we'll put 16x outside the bracket and divide everything by 16x to find out what's inside the brackets. Therefore, this is what I'm going to get. And notice I've just flipped the equation just to, because it's writing convention style. And now what I'll do is, because this is in now the same format as the null factor, because this can be written as like 16x multiplied by 2x minus 1. Notice it's now in the same format as the null factor. Therefore, I can equate each of these terms to 0 to solve for x. So therefore, 16x is equal to 0, 2x minus 1 is equal to 0. We know that if you're trying to solve for x in this case, divide both sides by 16. This is going to be equal to 0, duh. And for the next one, 2x minus 1. So therefore, we'll move 1 to the other side and then divide both sides by 2. X is therefore going to equal to half. And make sure you include the word or as well. We're going to now get you to answer some of these questions. So give yourself 3 to 5 minutes and then we'll compare our answers together. Now for the first question over here, what you should have done is rearrange the 3x to move it to the same side as x squared. So therefore, this is what you should get. And then afterwards, find out what is your highest common factor. Your highest common factor for this question is going to be x. Therefore, once I've got it into this format, notice it's now in the same style as a times b is equal to 0. Therefore, x is equal to 0 or x minus 3 is equal to 0. We've got one solution over here. So therefore, to find out the next one, we'll just rearrange. X is equal to positive 3. Therefore, x could either equal to 0 or positive 3. For my next example, your highest common factor is equal to 9x. I factorize it as such, and therefore I'm going to equate 9x equals to 0 as well as x plus 3 is equal to 0. You divide both sides over here by 9. Therefore, x is going to equal to 0. And for this one over here, I've subtracted both sides by 3. Therefore, x is equal to negative 3. And that's my solutions over here. And I'm hoping that you guys were able to answer this without any problems at all. Now we're going to look at another example. So we're going to be factorizing, but this time we're using dots, okay? So in this case of here, this kind of resembles a difference of perfect square. You've got two squared terms over here, although 15 is not really a squared term at all. And there's a subtraction sign that's separating between these two terms. So what over here, because I know that this is what the dots should look like, I'm going to rearrange my answer to look like something like this. So therefore, you could write this as x plus root 15, x minus root 15. And now that's in the null factor law, I could therefore go x plus root 15 is equal to 0, x minus root 15 is equal to 0. And therefore, this is going to be your answer. So now please have a go of answering these questions over here. As you can see, it kind of goes up in terms of difficulty, but I believe that you guys should be able to do it. For the very first example over here, in this case, you should be able to identify your a value is going to be 3 x, and your b value is going to be 5, okay? So remember, in order to do that, you just square root both terms. So therefore, in this case over here, my equation is going to be 3x plus 5, 3x minus 5. Sorry that it's kind of blocking the way. And therefore equate both terms to equal to 0. Therefore, 3x is equal to negative 5, or 3x is equal to positive 5. X is equal to, therefore, negative 5 on 3, or x is equal to positive 5 on 3. In this second example over here, before you even proceed to use DOPS, you should have recognized that there was a common factor present, so you should always be taking out the highest common factor before you even use any other methods. In this example over here, the highest common factor is going to be 3. So I've taken 3 outside the bracket as shown over here, and because we're trying to solve for x, in this case, I'm going to divide both sides by 3. And now my equation will look like x squared minus 16. At this point of view, you can easily see that this is a nice perfect square, a difference of perfect square. So therefore, your DOPS is going to be x plus 4, x minus 4 is equal to 0, equate them to equal to 0, and solve for x. So therefore, this is going to be your answer. For my next example over here, what I've done is I've subtracted 1 from both sides of the equation. So therefore, 4x squared minus 49 is equal to 0. Now, in this example over here, you can actually say that this is a nice perfect square. That's a nice perfect square because your a value in this case is going to be equal to 2x. Your b value is going to equal to 7. So therefore, this is now my DOPS. I'll therefore equate each of these factors to 0 and solve for x. So therefore, this is the answer you should be getting. Now, in our last example over here, I'm going to show you how do you actually factorize using the product sum method. And for this particular example, I've deliberately chosen a slightly more challenging-ish one, but it's not too different, okay? So in this case over here, before we actually can factorize it, I'm going to first expand it and rewrite it in a format that looks like a quadratic trinomial. So in this case, I'll expand it first. So therefore, this is what it will look like. And I'm going to move 4x and 60 to the left-hand side of the equation. If I do so, this is what my equation would now look like. And once it's in this format over here, I could then start to use the product sum method. So I'm going to look for two factors, multiply each other will give you negative 60. But these two factors must add up to give you negative 4. In this case over here, it's going to be positive 6 and negative 10. Because if I multiply those two numbers together, it will give me negative 60, but 6 take away 10 is going to give me negative 4. So therefore, I'm going to write my answer like this, and I'll equate each of these factors to 0 and then solve for it. So therefore, x is equal to negative 6 or x is equal to positive 10. Now, what I'd like you to do now is give yourself 5 minutes to answer these questions over here. For my very first example over here, you should have recognized that your factors that goes into 6 that add up to negative 5 is going to be positive 1 and negative 6. Equate them to 0. Therefore, x is equal to negative 1 or x is equal to positive 6. For my next example over here, it's a bit different, but again, I'm just trying to show you guys that whenever there is a common factor present, take that highest common factor out. So therefore, in this case, I've taken 2 out in this case, and then I'll divide both sides by 2. Once I've done that, then I can use the product sum method in this case. In this case over here, two numbers multiply each other gives me negative 12, but adds up to negative 1 is going to be positive 3 and negative 4. And therefore, we will equate it to 0 and solve for x as per usual. In my last example over here, notice that you do not have any common factors present, and we're going to be using the grouping method when you have I suppose a non-monic. So this is a non-monic, and that just means that the coefficient in front of x squared is not equal to 1. So what we need to do is we multiply the values of a and c, so that will give you negative 30. And we're trying to find two factors that gives you negative 30, but adds up to negative 13. In this case over here, you'd recognize that it's going to be positive 2 and negative 15. And once we do that, then I've rewritten my equation in this particular format over here, okay? So I've got 2x minus 15x, because that's the same thing as writing negative 13x. Once I've done that, the grouping method involves us factorizing the first two terms and the last two terms. So therefore, this is what my equation would now look like. And notice that you now have a common binomial factor. So if I was to factorize this is what my equation would now look like. And now, once I've done that, then you just use the Null Factor Law. Therefore, solve for x. X is equal to 3 on 2, or x is equal to negative 1 on 5. What I'd like you to do now is I'd like to get you to answer the following textbook questions. So answer questions 2, 3, 4, questions 5, 6, and 7. And these questions over here, they're more of an extension question. So if you can do this, it'll be great. If you can't, then don't worry about it too much. This is pretty much the end of today's video. Hopefully you're able to meet the success criteria of this lesson. I'll see you guys again in the next video. Bye.